student. Hello students, now we will be doing the images formation by the concave mirror. Okay, in a concave mirror, now for making a concave mirror you have to use a pencil with the protector or with a compass. You can make the concave mirror. This is the back side of the mirror, while this is the reflecting part of the mirror. Then you have to select the midpoint of the mirror, that is known as a pole. Okay, then you have to extend a line which is called the principal axis. Then you have to select a point which is called the center of curvature. Then the midpoint of pole and the center of curvature should be the focus. So these are the consideration you have to make it. Now in a concave mirror, it has been found that when the object is very far away, then the image will be formed at the focus. Okay, as the object is brought nearer, let me use the black line to show the object and the green line to show its image. Like when, suppose here is an object, let me represent the object by just a line, extended object, big object. When the object is very far away, then its image will be always appear small and it will be near to the focus. Okay, near to the focus. If the object is at infinity, the image of it will be at the focus point size. If the object approaches nearer, okay, the same object, when the object approaches nearer, then its image will shift towards the center of curvature with increasing size. Like this object is approaching, now its image will shift towards this side, towards the center of curvature with size increase. As the object approach nearer, the image will shift towards the center of curvature with increase in size. Sorry, the size should be less than that of the object. As it comes nearer, the image should shift towards the center of curvature. I think the text have used the term C for that. Now when the object is exactly at C, its image should be directly down, inverted and at C, same size. Okay, so this is the thing. So when the object is brought from far away, then its image will shift away from the focus towards the center of curvature with increase in size. Now when the object is approaching, now as the object is approaching the focus, now the image will keep on shifting. Nearer the object, the image will keep on shifting with increase in size. So as the object is approaching nearer, the image is shifting away from the focus with increase in size. So and when the object is at F, the image will be very big and it will be formed at infinity. This word very big, we use the term magnified, and the image will be very far away. Okay, I hope my explanation is clear for this. As the object is brought from away towards the mirror, then the image of it will shift away from the focus towards the center of curvature, and this way it will go with increase in size. Okay, now there comes an exception for the object between the pole and the focus. When the object is in between the pole and focus, then its image will be virtual and its image will be magnified. this will, we are going to see it how it comes. Okay, so as the image is moving towards from the focus towards the pole, then the image will get magnified, and because of this the dentist uses the concave mirror. Okay, let us see how the images of it will be formed. So we have to use just those ray diagram, what to say, the rules. Of the 3 rules, we need to just apply the 2 rules. Let's see, let me apply one of the rule. Suppose here is, sorry, suppose here is a concave mirror. Pole, center of curvature. Previously I was using O, but as the text is using C, so you have to stick with the C. Then the midpoint of it is the focus. Now let me choose the object at object beyond C. Let's say the object is beyond C, somewhere beyond C. Let's say I will represent the object by means of line. This shows the head of the object, while this is the tail. Now the object have to be kept always perpendicular to the principal axis. Okay, now let us apply the rules. Okay, now we will choose any point. From that point we have to take 2 rays. Okay, now we will be choosing the head of the object. So then from the tip, now apply the rule. Incident ray on passing through the mirror, the reflected ray should pass from where? From the focus. We have used 1. Okay, now this is one rule we have applied. Let us apply another rule. We can apply the rule number 2 for this case. Now the incident ray on passing through the focus, the reflected ray should pass from where? From the, should be parallel. Now the reflected rays, these 2 reflected rays, they are meeting at this point, right? This point is the point of the tip of the image. All right, similarly we can do for that this part of the object, we can do this part of the object, we can do this part of the object, and when we do this, how the image will come? The image will come upside down. So how the image is? The image is, in this case, this is the image, so the image is upside down, right? Image, how it is? It's upside down. Upside down, we use the word inverted. Inverted, then I have said how it should be. It should be smaller because it's approaching the, it's approaching where? It is approaching the mirror. So as it approaching the mirror, the image should shift from the focus towards the center with increase in size. Okay, so it will be, we use the word diminish, diminished. Okay, so it is inverted, diminished. The reflected rays are really meeting, so we call the image real. So this is the nature of the image. So any rule, any image you can make by applying the rules for any position of the object. You can see this one in detail from the textbook. You can see the textbook, I think it's page number 8, 7 and 8. I have one more, let me do it. Pole, center of curvature, focus. Let me keep the object over here. Okay, here is an object, let's say, between pole and focus. Now the light ray incident parallel to the principal axis, what will happen after reflection? Should pass through the focus. Now let me apply another rule. Now a light which is normal, we have to use a little bit of geometry construction for that. First of all, for this position where the image should be, behind the mirror, right? Now using a scale, if we simply extend, right, incident ray goes this way, reflected this way. Now these two rays are diverging, so they are not going to meet each other. However, when we produce them backward, then they will meet at this point. So this should be the tip of the image. How the image looks like, basically it will look thicker and it looks bigger. So how we are going to call this? This is magnified, and they are not really meeting, so we call it virtual, and it is erect. So see the textbook, page number 7 and 8 if I'm not mistaken, and learn the ray diagram for the concave mirror.